So for those who don't know me, my name is Cody Arlen. I'm a technical marketing architect with the Cloud Management Business Unit, similar to John, who presented previously. You can follow me on Twitter at Cody Arkland. An interesting thing about me is that I was actually a customer of Vera's automation before I came aboard at VMware. So I'm very familiar with probably many of the opinions and some of the complaints that people had about the way the product was leveraged previously and the way it was installed previously. I've been a part of the team that helped design and take this product to market since its early days, about a little over 2 years ago, closer to 3. There's 3 products in here we're going to talk about today. I had a little bit of blur on the screen, so let's see if I can do a little refresh and clean that up a little bit. We're going to be talking about Cloud Assembly, CodeStream, and Service Broker. Ken touched on these a little bit previously. Cloud Assembly is our blueprinting engine. It's where we're creating these bindings to cloud accounts. We're connecting to things like AWS, GCP, Azure. We're building zones and tagging these zones so we can deploy workloads across those environments. We're building blueprints, setting up projects. Service Broker is where we're delivering that catalog experience. How do we make this available for traditional users to come in and consume these catalog items? And then CodeStream is our DevOps platform where we're delivering, I don't like to say DevOps platform, it's more of a CI/CD platform where we're delivering pipelines and driving automation from a pipeline perspective. We have a little bit different approach on each of these themes, but something that I want you to take away from this conversation, I know many of you in the room have used Vera's automation. Vera's automation was very much focused on a single type of consumer, the user coming into the catalog and requesting a thing. And what we've changed in Cloud Automation Services is address that there are a number of ways people consume services now. Some people expect to be able to consume services in a completely automated fashion, meaning they commit a code into a GitHub repo or GitLab repo, and it fires off some form of automation in the background. They don't even want to know that a platform's involved. They want to just trigger off. Some people are coming in via API, and they're saying, I don't ever want to touch a GUI. I want to request 10 machines on a loop and have it go out and build those out asynchronously, right? They don't want to touch it at all that way. They want a command line experience. They want to come in and very similar to an apply statement, right? I want to apply my blueprint and go. And then you have the people who are used to working inside of a GUI and aren't necessarily bothered by it. You also have people who want to be building blueprints and designing and then consuming. We've recognized that you can't have a platform that is focused on one type of consumer and have it be relevant. We have to address the fact that there are a number of different ways people consume these services. So as I go through this, I want you to pay attention to the fact that there's a number of ways these are consumed, and I'll do my best to highlight those and show those. But as you have questions about the ways people consume the service, please feel free to speak up. Speak about any question, but especially that one, because it's definitely a founding principle of what the platform does. So we're going to jump into Cloud Assembly and get started. We're going to deviate a little bit from the original agenda because I want to set a good foundation. We're not going to eat up any more time on it. We're going to stick to the same time frame that we had before. But we're going to deviate slightly from the original plan. So the first thing that a user is going to do when they come into Cloud Assembly is build out what are called their cloud accounts. I remember when I first built out my first Vera's automation environment, it was a minimum of 2 to 3 days before I could really get value out of that platform and be provisioning workloads, deploying workloads, and consuming things. And that's if I was on the ball, working in the platform. We're talking about 2 to 3 days at minimum. Another governing principle of Cloud Automation Services is if we can't provide value back from a provisioning standpoint in 15 minutes, you're not going to use the platform. You can absolutely receive Cloud Automation Services, sign in, and be provisioning workloads that are useful within 15 minutes. In a normal environment, I'd have none of these cloud accounts available. They would be completely empty, and I would add a new one. In this case, I have all of mine set up, but I want to highlight the different things we have available. AWS, Azure, GCP, both flavors of NSX, vCenter, and then VMware Cloud on AWS. Each one of these is a streamlined process for getting these added and onboarded into the platform. And when you add these cloud accounts, a process kicks off in the background that we call discovery. This discovery process collects different information about that environment. You can see I've clicked on the Compute tab, which is going to give me back my typical clusters, availability zones view. You can see I've discovered a number of different things in here. Amazon Web Services, Amazon Web Services availability zones, GCP zones, Azure regions, so on and so forth. You can see a couple of tags that have been established over here on the right. I'd have this tagged as things like vSphere, vGCP. These are free-form tags. We use tags within the platform to tell our blueprints where to provision. The platform is about abstracting out the complexity of reaching into each individual cloud to provision these workloads. So in order for us to achieve moving a workload into an environment, we use these things called constraint tags to place those workloads. And you'll see that when we jump into a cloud zones view and we go into blueprinting here in just a second. Important thing I want to highlight here is that we're collecting information about those clouds and using those resources. So we collect storage information, we collect networks, we collect machines, which we can then onboard into the platform if we want to. A direct output of adding a cloud account is something called a cloud zone. And as I talked about the tagging before, we'll go into a familiar area of vSphere. This is very simple, my little home lab clusters that I've set up. And I have a management cluster that's tagged as env vSphere. When I use that tag inside of a blueprint, the provisioning engine knows to place the workload onto that. Same thing applies for AWS. And if I have multiple AWS regions, I tag them differently. With clusters, it's kind of a basic example because in your head you're probably thinking, well, okay, that makes sense. But think of the use when you get into something like networking and when you might have a network profile that maps back to a specific wire that also maps back to security groups and being able to combine those all into one tag identity. So when I say app web server, it now lands on a specific wire and gets a group of security groups from NSX, T, or V as well. It gets really powerful when you start moving beyond just the compute aspect of things and you look at things like storage. If I want specific storage policies from vSAN to be able to be applied, I can do that via tag placement as well.
So that generically storage SPBM policies can be applied through those tags, or is it specific to vSphere?
So it's definitely it's SPBM from a vSphere perspective, but when you look at the public cloud, you also have those different types of storage types as well. So IOP limits, if you want to use SSD versus spinning disk, all of those are taggable as well. So you could have 10, 15 different storage policies with different characteristics and apply them as part of the blueprint. You could have a drop-down list that then you select from as part of your deployment process. We're focused on making the platform very consumable, right? That's what I talked about at the beginning. It's not just about how you consume the product, but it's how we consume services from public cloud and how we enable you to consume those services as well. So we're going to jump forward into blueprints because that's where things get a little bit interesting. I'm going to go ahead and create a new blueprint from scratch. We'll call this TFD01. And we're going to assign this to a project. A project is the logical evolution of what a business group was in Vera's automation. Projects are very lightweight, they're very flexible, and what projects do is they take you, the people, and give you access to provision into cloud zones. So you might have a project and you might say, hey, the web team is able to provision into AWS and vSphere. So you add those zones and now that project can access that. Those zones are reusable across multiple projects, right? So if you have 4 different projects, you can use that same zone across 4 of them if you want to. It's your call. I think there's a hand coming up.
Yeah, so you mentioned it's the evolution from vRealize automation, and you also said a little while ago that there was a ramp-up time to using vRealize automation.
Absolutely.
So is this offering going to be superseding that? Are they feeding back into each other?
It's the evolutionary steps. So the things you're seeing now will effectively become the next version of vRealize automation. Without diving too far into NDA territory, that part is publicly safe knowledge. This is what you're seeing now is the evolution of what vRealize automation will become.
Got it. Thank you.
Eventually. No NDA. So for that blueprint, I'm going to choose my project. Again, that project is how I take users and attach them to compute resources they can provision, or compute zones they can provision into, I'm sorry. For those of you who've been in VRA, this will look somewhat familiar to you. On the far left, as I scroll this over a little bit, on the far left, we have all of the resources I could provision onto the canvas. I have these cloud-agnostic objects which understand at an API level how to pivot between the clouds. So I can use a cloud-agnostic object and change that tag, and it'll natively understand how to take a vSphere VM that's based off of a template and provision an EC2 instance or provision a GCP VM. It understands how to pivot that workload between all of those without you changing the underlying blueprint at all. Conversely, I have all of the cloud-specific objects, things like an EC2 instance. And that EC2 instance is going to have some of the native cloud capabilities you would expect, like the ability to auto-scale, as an example, or from an Azure perspective, ability to bind to a resource group. So with the specific objects, we expose the capabilities of those specific clouds. For example, the vSphere object has the ability to call a template, or not a template, a customization spec, or to use a folder. You wouldn't place a workload into a folder in AWS, so that capability is not exposed to the EC2 object. For the case of this demo, we're going to drag out a machine. We're going to choose our image, and you can see as I drag this out, this infrastructure as code updates on the right. Interesting science fact, this is an actual declarative state, which means that when you deploy this, it is going to take the state of that deployment and store that as the record of that system. So that state is stored in the system's backend, very similar to other infrastructure as code platforms. It's not just dumping into the infrastructure as a service database like VRA used to. This is taking the state data and it is actually storing the state data. So when you modify it, that state is updated and we're always tracking the state of that deployment. So you can see as I'm updating this code, I'm getting prompted. So I picked Ubuntu for my image and I'm going to go ahead and do a medium deployment. When I hit enter, I get a set of autocompletes that are available. I'm going to go down to what is my constraints and I'm going to choose env AWS. Now it's a freeform tag. I wrote it that way. You might write pants and shirts as your tag. That's your choice. I do env against the cloud because it demos well, just to be clear. What we see many customers doing is taking that and being very intent driven. So they might say env compliance or env HIPAA, and that diverts it onto a specific cluster and onto specific storage and potentially gives it specific network characteristics as well. So this is done. I'm going to go ahead and version this blueprint. So I'm going to version this to 1. Simple machine deployment. And now I'm tracking that in version control within the platform. So that is tracked, and as I continue to modify this blueprint, I continue to save new versions, I can track the changes and the differences between those deployments as we roll forward. I'll go ahead and deploy this now. Now you'll notice, just before I do that, you'll notice I don't have a network attached on the bottom. It's going to infer the networks that are available for that zone and essentially just grab one that I've defined in the platform. So I've defined a set of network profiles, and because I've defined those out, it will look to see which one it will place on and place it there. And you'll see that in just a moment. So I'll do deploy. Call it Tech Field Day because I'm clever. And I can go to this build and I can see the history of that as it's building. So if I was doing a multi-machine build, I would see the different components of this building, and as they built, I would be able to see the status of each object. We started off with request in progress. It checked allocation to make sure I could actually place this workload somewhere, and then it starts to actually create the workload. If I click on this, I can come into what's called the provisioning diagram, and this is where it starts to become really clear the power of those tagging constructs and the power of the abstractions that we're doing here. I'm going to zoom this out just a tad. I have a representation of my project here that has the different zones that are available against it. I'll actually zoom right back in real quick so that everybody can see that much clearer. Below that, you can see all of the different cloud environments that were available for me to provision into. And you can effectively see a glimpse into what we call the provisioning engine. You can see how it's deciding where this workload goes. I specified a medium build. All of my clouds had a medium build available. I made mappings for each one of those, so those were available. All of my clouds had a Ubuntu image mapping available, so that was satisfied. However, when it came down to my tagging, I had specified env AWS as my tag, as the tag usage that I was using. And no other zones matched that, so they were all ruled out from the provisioning. This same process applies to storage and network in the exact same way. Pop back into deployments, that should be done. Fantastic. Within here, I have access to all of my day 2 operations for that, so I can change the lease, I can delete it. If I go into this topology view, I can interact with day 2 actions from that specific object within. Conversely, I can do the same thing from the actual canvas. I can come in, I can expand this, and I can see all of those available here as well. Getting a weird little resize issue on the screen, so sorry about that. Moving forward, if I want to make a small change to this, for example, if I wanted to drag out a volume, say I wanted to attach an additional disk to this machine, we can see as the infrastructure as code updates on the right, we're continuing to make these changes. I already have a storage profile set, so I don't need to tag it, but if I had multiple ones set, I could use those tags to pivot. We talked about that already. I'm going to version this up to version 2. I have this checkbox down here. We'll come back to this a little bit later, but that checkbox says reuse this or release this version into the catalog. This is a very extremely powerful capability that people don't realize. When you're working in vRealize Automation 6 or 7 today, and you want to create a new blueprint or a new service for your customers, the process to do that looks something like, I take an existing blueprint, I clone it, or say, I'm sorry, I create a new business group, I create a new reservation, I clone that blueprint, I assign it to a new entitlement that I only have access to, I make the changes, I decommission the old one, and I replace it. It sounds like a super smooth process, doesn't it? It's not a smooth process. It's actually pretty rough. This capability here allows us as administrators and advanced users to continue editing our blueprints while a released version exists in the catalog. Your users will see the released version. So if you've released version 2, you could be working on version 3, 4, 5, 12, 42, whatever, and choosing to only release the versions that you want users to consume. It's a very powerful way to be very agile in the way you're building blueprints and working in blueprints. So I've created that new version. If I come back into version history, we can do a comparison now because we have 2 in place. So I can choose version 1 and version 2. It's going to be pretty basic because we just added a disk, that's all. But you can see that as we would get more complex and add application constructs, this would be very useful to see the differences between versions of blueprints that different administrators had created.
Just a quick question here.
Shoot.
Because all of this is programming as well, and
Yeah.
I'm sure that there are interfaces that you can
Absolutely.
API calls and all those. So there's statements available that we can use by normal programming methods. What I'm getting at is that this is built into the interface. People have different ways of developing code
100%.
and code pipelines.
You're jumping ahead.
Oh,
Go, continue.
of course, my question was going to be that how well integrated you can make it to those external systems.
Wouldn't it be great if you could work on your blueprints from directly in VS Code and commit them into a GitHub repo and have that synchronized into a platform? Because there are different ways that people consume platforms now.
That's right, and that's
in the wee years of yesteryear, it was that you could only work on blueprints inside of VRA. And that was very restrictive, especially consider this. I built huge automation platforms and huge automated deployments in VRA. But when you told me, Cody, build me a SQL blueprint, I was clueless. Because I wasn't on the SQL team. I didn't know all the configurations that they had done specific to SQL servers. I could throw an ISO on and load it up, and I could fire up PowerShell and automate that. But ultimately, that group was the one building the scripts for delivering that. And it became very complex when I needed them to update a blueprint, but they're not VRA users and they just don't care, right? 100% agree with you. You're going to see it in a few minutes here. We do have the ability to directly interact with Git. We can have blueprints stored in Git and have it be a process where people are able to commit that code into Git, pull issues. We can collaborate together. You and I could be working on a blueprint. You could file an issue against mine. I could merge yours in, and then when that merge happens, have it push into the platform. And not just have it push into one project. We could have it push across the entire platform if we want, or we could have it push against a specific project. Beyond that, we can take that same model and leverage that against CodeStream, which is going to be kind of the final demo I do in this, where as you commit those blueprint changes, you can have CodeStream fire off pipelines that deploy that workload. Either deploy it into Kubernetes cluster, deploy it into a blueprint, or just take that raw infrastructure as code and shove it right into the deployment system.
And when that comes, can you also confirm that the pipelines can be others as well, not just CodeStream?
The pipelines can, other types of pipelines?
Yes.
So you absolutely could write webhooks that use other pipeline platforms. You're going to get, obviously, because we're VMware and we're building our own products, you're going to get better integration out of CodeStream. Like CodeStream is built to do this because that's how we use it inside. But you can absolutely use other platforms. Jenkins isn't a pipeline platform, but you could absolutely have the platform fire off a Jenkins job to call, or Circle CI wrote an integration for CodeStream to call Circle CI jobs and have Circle CI jobs execute blueprints. So it's absolutely possible.
Thanks, Chase.
So I could create a new deployment off of this, but oftentimes when you want to add a disk, you probably don't necessarily want to create a new deployment. Again, talking about the different ways people consume services, iterative development has become a thing where people will start with a very basic server. They'll start with a web server that's got their web and database on it, and then they'll be like, wow, that was a bad idea to throw my database on a system that's getting hammered by 150 users an hour. I'm going to break this out, but I don't want to destroy my entire platform to do that. These are the things that iterative development has kind of driven in IT. We adopt that same methodology in the platform. So I have this existing deployment. I'm going to hit next, and we're going to see a plan pop up. And the plan is going to specify that it's going to add a cloud volume, and it's going to update that machine with that cloud volume. This does nothing to destroy the existing machine in place or remove that existing machine in place. All we're doing is bolting on a disk. We don't need to destroy a machine to just bolt on a disk. So in this case, that's all we're going to do is bolt on that disk to that deployment. Now, where that will change is when we do like application level changes. So if I added on some form of an application component, it's going to need to reprovision that because that is considered a destructive action. You're changing the OS and you're changing the application. So I've got that all set. I'm happy with the way things are. I'm going to go ahead and release version 2 now. Last thing I want to highlight before I navigate out of blueprints for now, which we're going to come back to in a little bit, is VMware's always done deploying virtual machines really well. We have 1 million interfaces for deploying different virtual machine types, whether it's Power CLI, whether it's via Python, REST APIs directly, VRA, VRO. There's all these different ways to provision machines. But we've never taken the time to be aware of the fact that there are other types of compute resources out there. Things like RDS databases in AWS, S3 buckets, things like Azure-based SQL servers. Cloud Automation Services is aware of those constructs and allows you to provision those out as well. So as you can see on the left, I have things like Route 53, so I can do Route 53 DNS entries. I can do Redshift clusters, RDS clusters. I can call Lambda functions directly. One of our SEs out in EMEA has written an entire microservices application using Cloud Automation Services, and he has API gateway that he's used from the canvas, pointing back to Lambda functions, pointing back to S3 buckets that store static sites and to resolve that. And it all deploys cleanly using Cloud Automation Services. Couple things for the next section we're going to get to in just a minute, so just a little preview. We have the ability to integrate things like Puppet and Ansible in the platform as well as some of the NSXT NSXT and V constructs, so load balancers, networks, so on and so forth. Again, those are part of the next chapter of the demo.
So are all of these options exposed to you out of the box, or do they appear as you start adding your various cloud accounts into the system and connecting things, and then from there, does it show you what options you have?
So there's a feedback item on this that I've registered, and it's that if you come in with no cloud accounts and you click straight on blueprints, you'll see everything.
Okay.
And I wouldn't say it's necessarily a bad thing, because it's good to know what's there, and it's good to know, hey, if I saw S3 buckets and I know that's an important thing for me to be able to deploy, then I know I need to go buy my AWS account. But at the same time, I personally would appreciate the filtering aspect. I would appreciate, like, if anything that's bound, I can see. Otherwise, there's a drop down saying, things are missing, or some form of a UI catch on that. So.
But at the same time, if you're clicking through and you're curious, okay, if I add my Azure account to this, you'll be able to see exactly what is available to you right then and there versus
Absolutely.
Wondering, what can I do with this?
Absolutely. Absolutely.
There's another element where keeping up with the pace of innovation with any cloud provider is extremely hard. What are the provisions for AWS releases a new service? It's now available in my region, but it's not yet in the UI here. What are my options around consuming services that aren't yet in this, or that you maybe don't ever put in this?
Nothing if not transparent. There's going to be a lag, right? If AWS releases a new service, it's not going to be available day one, and we don't have API hooks to automatically do that. What I will say is the process for us to onboard those new services, you can see that we don't have every service exposed here. There's hundreds.
The UI is not nearly complex enough.
Right? But based on customer feedback, There's several that have been added, like the API gateway from the SE. We brought that up in an internal chat and said, hey, this would be really great. Customers can't use Lambda functions directly. They need an API gateway in front of it to call those. I mean, you just have to log into.
There's some ways to.
Yeah. But you get my point. Generally speaking, if you're doing a complex Lambda implementation, you're putting API gateway in front of it more commonly.
So in terms of a more general solution for the problem of pace of innovation, there is no way to do something like, say, I need to run some AWS CLI commands in the middle of this deploy process in order to hit features that aren't in this UI.
So yes, there is, and as part of the next portion of this, but that's fine because it's actually, we'll bleed it into this one and I'll do the next one as something else.